Hello and welcome to the second part of our complex unit, which is adding and subtracting complex numbers. Yay! So today you should be able to identify imaginary and complex numbers, so you should know what they look like, and be able to add and subtract them. So, as this says here, an imaginary number is a number whose square root is -1. So if I look at this, I take the square root, I solve it normally. The square root and the square are inverses, so they cancel each other out. And x is equal to plus or minus the square root of -1. Right? We have a special name for this. The square root of -1 is I. So technically, this is x equals plus or minus I. And that's an imaginary number. The imaginary number is the square root of -1. That's it. So anytime you see a negative under the radical, you know there's a square root of -1 in there somehow. And that's an imaginary number. This is generally how we write our imaginary numbers. We write our coefficients first, and then we write the I, and then the radical. Just so that we're consistent. So the I should always go between the coefficient and the radical. If there isn't a radical, then the I goes last, just like if it was if the I was an x. So when we reduce imaginary numbers, it's just like reducing radicals, except we have one extra step. We take out the I. It's always near Halloween that I do this, and I take out the I, just like I would on Halloween. No, I'm kidding. So I do this my first time. I go over this so that you can see where that I comes from. This particular step I generally don't do every time because it's really unnecessary. But if you know that the square root of -24 is the same as the square root of -1 times 24, because -1 times 24 is -24. So therefore, I know that the square root of -1 is I, so that's -2. Notice, this -2 stays -2. The negative under the radical here and the negative outside the radical can't connect. One's an outside, one's an inside. They don't go together, so leave them alone. And that's an I. Then I simply reduce that 24 the way I normally would. 24 is the square root of 4 times the square root of 6, so it's -2I times 2, because that's what the square root of 4 is, radical 6. Multiply the 2 and the -2, because remember this is just multiplication, and that equals -4I radical 6. And then we just keep doing it over and over and over. So the big deal and the big difference between this and what you did yesterday is that when you have a negative under this radical here, there should be an I on the outside. So to make this positive, we put an I here. That's it. Okay, nothing else changes. Sorry about the sirens. Okay, the square root of 64 is 8. It's a perfect square, so it's 4I times 8. And 8 times 4 is 32I. Here, there's a negative under the radical, so to make it positive, I put an I out there. So it's -I times the square root of 125. -I times 25 times 5. 125, perfect square is 25. Think of it as quarters. So 5 quarters makes 125. Square root of 25 is 5, so it's -5I radical 5. So take a second and pause and try the next 3. And I'll just quickly go over the answers when you're done. All right. Oh, look. Just as a check it out, it's really cool. If you don't have a negative under the radical, you don't have an I. I don't care that there's a negative on the outside. Doesn't matter. So this one is not imaginary. So there's no I needed. It's just 36 times 2. The square root of 36 is 6. Radical 2. No I, no negative under the radical, just a regular reducing. This one here, I know I tricked you on the first one. Sorry. This is, let's change it to blue here. You make that positive, so the I goes on the outside. It's all multiplication. Always, always, always multiplication. And then you just reduce. Great. Next one. So take that I out first. Positive I, negative 2, I, 81 on 2. Square root of 81 is 9. So it's negative 18 I radical 2. Now, we make the I a little curvy like this, no particular reason. So, it's just not capital. It's a lowercase I. Alright, next part is you have to be able to look at a complex number and know the different parts. So a complex number has a real and an imaginary part. So the imaginary part is obviously the I, and the real part is the one without. So A and B themselves are real numbers, but the I attached to the B in multiplication, that just makes it imaginary. So if you look here, take a second, pause it, see if you can figure out what's A and what's B in each of these. So here A is 2, B is 4, here A is 5, B is negative 2, here A is 6, and B is 0, because there is no imaginary part. Okay, this one here, a little bit trickier. This 2 is on the bottom, so the 2 goes into the 5 and the 10. So if rewriting this would be 5 over 2 plus 5I. So then that tells you that A is 5 over 2, B is 5, A is radical 7. Here, even though it's written opposite, because that's just the way we write it, it should be negative radical 3. And here, there is no real part, because this is 0 plus 3I, so A is 0. Okay, using that information, we can graph complex numbers. So if you know what A and B are, you simply pretend that A is your X, and your X-axis here, here, and B is your Y, and this is your imaginary line, and you simply graph it. When you do graph it, it's a ray starting from the origin to that point, or a vector, we call it. So this one, 3 plus 4I, you would graph 3 comma 4, 3, 4, put a little dot, start at the origin, and put an arrow. 2, negative 3, would be 2, negative 3 here. Put the dot, arrow from the origin, and then that's it. If there's no imaginary part, then it's on the, it's just 3, like this one. If there's no real part, then it's just on the y-axis there. So moving down here, we are going to graph these numbers and their conjugates. Okay, so just as you can see here, it says a conjugate is a binomial formed by negating the second term of a binomial. So here, this is a binomial, it's got 2 terms. This is the second term, and that's its sign. So its conjugate is 2 plus 3i. This one, you just change the middle sign again. So it's negative 3 minus 2i. And this one, just change the middle sign. There we go. So now to graph these, I'll graph these each in a different color. Graphing this one, remember that I want to graph the 2 as your x and the negative 3 as the y. So 2, negative 3 would go here, and just draw a little vector right there. And 2 plus 3i is here, draw a vector there, and that creates you drawing your binomial and its conjugate. So it's actually a reflection in the x-axis. So the next one, I'll do in red, negative 3 plus 2i, be there. Negative 3 minus 2i is right there. Negative 1 plus minus 4i. And negative 1 minus 4i. And negative 1 plus 4i. So all this is reflecting that through its x-axis, just changing its middle term. Lastly, we're just adding and subtracting. So when you add and subtract, you follow the same rules we did before. You add by reducing the radical first, if you have it, and then adding like terms. Alright, so for this one here, these are all perfect squares. I can just see that now. Hopefully by this point you can see that. So I'm simply going to add 6 plus, and this is 2i, radical 64. So it's always, if you want to just do that, that's fantastic. Okay, but you need to get rid of that negative because it is very confusing if you don't. Okay, do the radical 64, that's 8. So it's 2i times 8. So this is 6 plus 16i. Then here we do 2 times 7, or 14. And we're adding these. And then this one here is negative I times 5, or negative 5i. Now we just simply combine like terms. If you want, you can line them up here. And then add 16 plus 4, 6 plus 14 is 20. And 16 minus 5 is 11. Okay, try this one on your own, pause it, and then come back when you're done. Square root of 16 is 4. When you're here, remember, make that positive, put the I there. So then this is 2i times 9. So that's plus 18i. Now we were subtracting here, so it's minus. The square root of 100 is 10. This number right there. So the square root of 4 is 2, so it's minus 2i. Stays minus 2i. That negative under the radical does nothing to the outside sign. So now we're subtracting. So we add the opposite. We need to change the signs of both of those. Line it up. Add them up. Negative 6 plus 20i. Alright. Hopefully I'm adding right. So here we're just no reducing necessary. Just add or subtract. Try it out on your own. Alright, combining like terms, you can line them up or you don't have to. So it's 7 minus 2i, we're adding. So signs stay the same. Moving on, subtracting, got to change the sign, so add the opposite. So that's positive 5, so it's negative 5. Negative 7, positive 7. And add it up. Negative 3 plus 10i. Okay, try these guys on your own if you haven't done it already, and just check your answers with me. So here the end should be 9 minus 6i. This one is subtracting. Remember, negative 5 plus 7i. So it's negative 3 plus 10i. job, exact same problem. Well done. Oh, sometimes. Oh my god. I stink. Oh well, sorry guys. You got them right. Good job. Okay, now graph the following and find their sum and what quadrant is the sum in. So you want to graph 2 plus 4i. So hopefully you've tried this already. 2 plus 4i, 2 on the x-axis, 4i there, and that's that. Negative 1 minus 3i, negative 1 minus 3. Now that's awesome. Now they want you to, I want you to find the sum and graph it. So simply add those guys up. So it's 1, 2 minus 1 is 1, and 4 minus 3, or 4 plus a negative 3, is positive 1. So 1 and 1. Maybe I should, hold on, let me make this a little bigger, because, ooh. Alright, there we go. That's a little guy. That's fun. Alright, so you get the idea. It's in quadrant 1. Maybe you remember that from geometry or any other time that you graphed. If you're doing quadrants, it starts here, it goes in a big C. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. So this particular one is in quadrant 1. And there we go. Have fun.